Good morning, my dear students. It gives me great pleasure to talk to you students through video presentations like this as usual. In this particular video presentation, we'll continue with the remaining problems on integration from exercise 7.5 from the NCERT textbook. The first problem meant for today goes like this. Integral 2x dx divided by x square plus 1 into x square plus 3. This can be written as dt by t plus 1 into t plus 3, where my t is x square and t is x square, dt is 2x dx. We can avoid partial fraction. I can write the numerator as t plus 3 minus t plus 1. Write like this: dt divided by t plus 1 into t plus 3. Here anyway t gets cancelled. 3 minus 1 is 2. To compensate, divide by 2 outside. Make it as 2 integral half integral t plus t dt by t plus 1 into t plus 3 minus half integral t plus 1 dt by t plus 1 into t plus 3. Here t plus 3 gets cancelled, here t plus 1 gets cancelled. Can be written as half integral d of t plus 3 by t plus 1 by t plus 1, t plus 1 by t plus 1 minus half integral d of t plus 3 by t plus 3. Therefore, this will become half log mod t plus 1 minus half log mod t plus 3 plus c, which will get reduced to half log mod x square plus 1 by x square plus 3 plus c will be the final answer. That will be the final answer. Let me just repeat the whole process. The second step, I can write this as dt by t plus 1 t plus 3 by taking t as x square. Therefore, just to avoid partial fraction, I'll write the numerator as t plus 3 minus t plus 1. T gets cancelled. 3 minus 1 is 2, divided by 2 outside. Make it as 2 integrals. Here t plus 3 gets cancelled, here t plus 1 gets cancelled. I already told you to write d of t is dt, d of 1 is 0, d of t is dt, d of 3 is 0. So to form d of f of x by f of x, the format half log mod t plus minus half log mod t plus 3 plus c, half log. You can even avoid modulus here because x square is always positive, x square plus 1, x square plus 3 will be always positive. Without writing modulus also, it is correct. It is not at all difficult to follow. I'll explain the next problem. Next one, integral dx by x into x power 4 minus 1. Just multiply and divide by x cube here, x power 4 into x power 4 minus 1. Here I mean to say derivative of x power 4 is 4x cube, therefore multiply and divide by 4 in the next step. Divide by x power 4 into x power 4 minus 1. This can be written as dt by t into t minus 1, where my t is x power 4. Therefore, I can write the numerator as t minus 1. It's not difficult to follow. T minus 1. It is by t into t minus 1. Here t gets cancelled, minus of minus 1 is plus 1. Therefore, 1 by 4 integral t dt by t into t minus 1 minus 1 by 4 t integral t minus 1 dt divided by t into t minus 1. Here t gets cancelled, here t minus 1 gets cancelled. This is 1 by 4 integral t of t minus 1 by t minus 1 minus 1 by 4 log mod t plus c. Here it is 1 by 4 log mod t minus 1 by t plus c. I'll just write the final answer over here. This is 1 by 4 log mod x power 4 minus 1 by x power 4 plus c will be the final answer. X power 4 minus 1 by x power 4 plus c is the final answer. It is not at all difficult to follow. Let me explain once again. Here, multiply and divide by x cube in the second step. Derivative x power 4 is 4x cube multiplied by 4 in the next step. This can be replaced by dt by t into t minus 1, where t is x power 4. Write the numerator as t minus 1. T minus t gets cancelled. Minus of minus 1 is plus 1. Make it as two integrals. T gets cancelled. T minus 1 gets cancelled. It's better to write as t of t minus 1 by t minus 1, because students have the tendency to write even by dt by t square is log mod t square, which is wrong. So to form du by u, d of f of x by f of x, d of f of t by f of t, either way you can write 1 by 4 log mod t minus 1 by t, therefore replace t by x power 4, 1 by 4 log mod x power 4 minus 1 by x power 4. You can have a generalization. Integral x by x into x power n minus 1 by n log mod x power n minus 1 by x power n. Integral x by x into x power 6 minus 1 by 6 log mod x power 6 minus 1 by x power 6. Integral x by x into x power 100 minus 1 by 100 log mod x power 100 minus 1 by x power 100 plus c. You can have infinitely many such cases. You can have a generalized case also easily. It is not at all difficult to follow. It's very simple to remember and follow. It's very simple. It's not at all difficult. For the 21st problem, it is given integral dx by e power x minus 1. This is also an easier one. I'll just explain. I'll give you an easier method everywhere. Just remember carefully. Integral dx by e power x minus 1. Integral dx by e power x minus 1. What I will do is multiply and divide by e power x in the next step within the integral. I should not take variables outside the integral. This can be written as dt by t into t minus 1, where my t is e power x. Now for here again, as in the previous problem, numerator can be written like this, by t into t minus 1. Now for integral t dt by t into t minus 1 minus integral t minus 1 dt by t into t minus 1. Here t gets cancelled, here t minus 1 gets cancelled, can be written as d of t minus 1 by t minus 1 minus integral dt by t, which is log mod t minus 1 minus log mod t plus c. For final answer is log mod e power x minus 1 by e power x plus c. That will be the final answer. It is not at all difficult to follow. I hope it is easier to follow. I'll just explain once again. Multiply and divide by e power x within the integral. E power x being a variable should not be taken out of the integral. This can be written dt by t into t minus 1. T is e power x. When t is e power x, dt is also e power x dx. Write the numerators t minus 1. T minus t gets cancelled. Minus of minus 1 is plus 1. Divide individually. Here t gets cancelled. Here t minus 1 gets cancelled. This can be written d of t minus 1. Therefore log t minus 1 minus log mod t. Therefore log mod e power x minus e power x plus c. E power x minus 1 e power x will be always positive. Without writing modulus also, it is correct. It is not at all difficult. It is not at all difficult. Okay, next of course for the 22nd problem, it is integral x dx by x minus 1 and x minus 2. Integral x dx by x minus 1 and x minus 2. That is the next problem. This is your 22nd problem. Integral x dx by x minus 1 into x minus 2. Let x by x minus 1 into x minus 2 is equal to a by x minus 1 plus b by x minus 2. Therefore x is equal to a into x minus 2 plus b into x minus 1. Now substitute x equal to 1 in 1. We get 1 is equal to minus a plus 0, which implies a is minus 1. Substitute x equal to 2 in 1. We get, what do we get? 2 is equal to 0 plus b, which implies b is 2. Therefore integral x dx by x minus 1 into x minus 2 will automatically become, what is my a is minus 1. Therefore this is reduced to anyway minus d of x minus 1 by x minus 1 minus integral d of x minus 1 by x minus 1 plus 2 integral d of x minus 2 by x minus 2. Therefore this will become minus log mod x minus 1 plus 2 log mod x minus 2 plus c. Therefore this will get reduced to x minus 2 whole square by x minus 1 plus c. That will be the final answer. That will be the final answer. Is given as an option here. Option here is anyway b. Option here is automatically b. Option here is automatically b here. Option here is b. Let me just explain once again. X divided by x minus 1 x minus 2 can be written as a by x minus 1 b by x minus 2. Therefore, after taking LCM, x equal to a into x minus 2 b into x minus 1, substitute x equal to 1 in 1, 1 equal to minus a plus 0, a is minus 1. Substitute x equal to 2, 2 is equal to 0 plus b, b is 2. Therefore, this gets reduced to minus log mod x minus 1, 2 log x minus 2. This can be log mod x minus 2 whole square by x minus 1. Answer is B in the textbook. Answer is B in the textbook. It is not at all difficult. You need to just, I am explaining everything twice. If you understand thoroughly, each and every problem is easier. It is not at all difficult. Here it is x into x square plus 1. So multiply and divide by x here. X square into x square plus 1. Multiply and divide by 2. 2x dx by x square into x square plus 1 can be written as dt by t into t plus 1, where my t is x square. Therefore, I can write the numerator as t plus 1 minus t dt by t into t plus 1. This is reduced to half integral t plus 1 dt by t into t plus 1 minus half integral t dt by t into t plus 1. Here t plus 1 gets cancelled, here t gets cancelled. Therefore, finally it gets reduced to half integral dt by t. This gets reduced to half integral dt by t. I mean to say half integral dt by t minus half integral d of t plus 1 by t plus 1 plus c, which is half plus c can be written later. Half log mod t minus half log mod t plus 1 plus c, which is half log mod my t is x square by x square plus 1 plus c. My answer is, anyway, a. Here's left out over here anyway. Half log x square minus half log x square plus 1 is the final answer. Okay, again he writes it as, for a he writes it like this: half log mod half into 2 into x log x minus half log x square plus 1. This is how the answer is given. 2 gets cancelled. This is how the answer is given. That is my answer is A. Answer happens to be A. My answer happens to be A. This C won't be there. This 2 is taken down here. Log x power p is p log x, using that rule, power rule of logarithm. So my answer is A. Let me repeat. Multiply divided by x here within the integral. You should not take a variable outside the integral. Multiply divided by 2 becomes dt by t into t plus 1. Numerator is t plus 1 minus t. Divide individually. Integrate dt by t minus half log d of t plus 1 by t plus 1. Half log mod t minus half log mod t plus 1. Forget about this to get the book answer. This can be written as half log x square can be half into log mod x. You can even put log modulus over here. You can put modulus over here. So log mod x minus half log mod x square plus 1 will be the final answer. Answer is A here. It is almost 13 minutes. The rest will continue in the next video. Thank you students for patient watching.